Right, welcome everyone. So, and Damien, thanks for the introduction, because that saves me quite some time on the why we started Energy, or not so much the why, but that we started Energy in 2021. So I think most of the people know us from the Wegenwacht, and Energy not so much. Up until 2021, that's logical, because we didn't start. And in 2022, we started selling Energy. And the reason why I think it's an interesting one to show, because it's from a lot of people that we talk to, we sell Energy, they don't really understand it at first that we are doing it. And why? Because it's all about cars and bikes, right? So, but it actually started off in the innovation department. They continuously scan for all sorts of different challenges and that we have as a society. And one of them that came across was the energy system, basically. So this is actually tells kind of the whole reason why we started. So we looked at electricity, and we saw that there's a lot of more electricity coming from intermittent sources. So it's a very sophisticated word to say, well, this sun and wind power, which is not always there. And we come from an energy system where power came from coal and gas. That's always there. You can ramp them up and ramp them down, whatever the demand changes. So it's a supply or like a demand-driven system, basically. But it changes, and we're now at 50% of renewables. The goal, obviously, is to actually go, well, ideally up to 100. So that system is changing a lot, and the system will change even more. And the difficulty with the power grid is that supply and demand have to be equal at exactly the same time always. So there can't be any switch. So whenever we change our behavior in terms of energy consumption, some supply has to change as well. So you can imagine that if there's less wind or less solar and you can't really sort of like influence the solar radiation or wind, that imposes a challenge. And then a second challenge, slightly related but a little bit different, is that the grid is also congested. So we are actually shifting away from natural gas to power. But what we are also seeing is that the grid is not able to change as fast as we are changing our consumption and behaviors. Building a substation can take up to 10 years or something like that. So if we look at the map from the Netherlands, from a grid operator's perspective, it's basically all red or orangey, which kind of means if you come in and you want a new connection, they'll tell you we can't. So there's now, I think about it, 10,000, over 10,000 different companies that can't get power right now. A big problem, especially also from an ABB perspective, because electricity is used for driving cars more and more. So basically those two were the main drivers for us to look into. A third one, very important, ABB is a hugely trusted brand, but our competitors are not. So the main competitors, they're, well, people at home, they don't really trust them. And well, we thought, well, that's some sort of a gap that we can fill in. And why? Because we see that we need to change something in the system. So there's intermittent supply. There should be something in terms of demand that should change with that. At least that's what we think. So that's the reason why we started to sell Energy. And also important to know that congestion means it's not always congested. It's a few hours during the year where it's congested. But obviously those few hours are very relevant. But if you can switch away from a few hours, or during a certain type of day, you can switch your charging to night or during the day, you can help sort of like relieve the pressure on the grid. But that requires that you know at each point in time what power is consumed, and you can shift it away. So there's a lot of sort of like time of use involved here. And that also requires us to know when something is consumed or produced. And that's very easy. It starts because we have just a lot of smart meters at home. So you have a meter reading for every 15 minutes. It tells you how much is produced and how much is consumed. But it is a lot of data that we have there. But about more than 90% of the customers have it. So what we introduced and what's different compared to all the other energy companies there is that we thought of, well, if we have all of that data, all the smart meter readings, we know that the grid is congested only for a few hours a year often. That there should be something to help to switch our consumption up until, well, different moments. That's why we decided we are not going to go into fixed rates. So most of the people here, they have an energy contract and you have a fixed power price. Well, what we said, well, we are going to introduce dynamic tariffs. And it sounds a little bit weirdish, but this actually makes sense because each day there is a power exchange, and then supply and demand meet, and they get a certain price. It's currently every 15 minutes. It used to be every hour. And basically what we did is, well, if we fast forward that price to the consumer, they will have all the incentives that they need. Because if the power is very cheap, that means that it's, well, quite heavily available. A lot of sun, typically, or a lot of wind. And then we want to stimulate more consumption. But the other way around also happens. If there is a lot of expensive electricity prices, that's also the moment where a grid is actually typically congested and where there's not a lot of renewables. So you're not really utilizing that renewable energy to the max. Therefore, some gas or coal-fired power plant needs to ramp up. So that's what we started. We think that's a solution, or at least part of the solution in the energy transition. But, as I said, it is a lot of data. So we have about 200,000 customers that have a smart meter, and it produces data on every 50 minutes for production and consumption. And we need that because we are billing them by the hour. So we need to know at each 50 minutes what they need to do. So right now it's by the hour. In the future it's going to be 15 minutes probably. But also the purchasing side. So we need to source the energy. And there's also a lot of data coming in that we need to source it right. So if we are sourcing the energy, we need to tell the grid operator as well, we are sourcing so much energy, it is 15 minutes. And to make that prediction or to make that operation go smooth, we also need all of that data. So that's a challenge, a big challenge, a relatively new company. So then we asked Valerie and her colleagues to help us out to fix this problem for us. And they did. Yeah,
yeah, thank you. Thanks for the introduction on the energy usage. So I will talk about the technical implementation of how we manage to process all of that huge amount of data. So to start with, I want to show you the starting situation in January 2025 when we first joined ANWB. So this shows the data flow all the way from data source to visualization. So we get data from Kraken and Energy Zero. So ANWB was actually in the process of migrating from Energy Zero to Kraken. And we then store the data, or used to store the data in PostgreSQL and in Arizona S3 buckets. And the data was then transformed in Snowflake, which is the part that I will focus on in my presentation. So back then it was mostly done with Snowflake worksheets. So if you're familiar with Snowflake, you might know that worksheets are like Jupyter notebooks. So it's just a way to transform the data using SQL queries. And what I mean by transformation is to, for example, remove outliers, to clean the data by removing any null values, by joining data from different sources, like all these kinds of things that I will also go into more detail later. But most of that was done using worksheets. And the problem with worksheets is they were not version controlled. So that means that the changes that people were making were not really tracked. So that makes it difficult to see why things have changed. Maybe somebody in the team changed something in the query, and then other people wouldn't know exactly why this has changed or how to revert those changes. So that is one issue with worksheets, and also the lack of data tests. So that also reduces the reliability of the data. If you don't have automatic tests that check whether anything has changed or whether there's anything unusual going on. Then lastly, it was visualized with Power BI, which is still the case now. but the image looks a little bit different now. So what I want to focus on is, again, the transformation part. So we're still using Snowflake, but now the transformations are done in dbt. So dbt you've probably heard a lot about today already, so I don't want to introduce it again too much, but basically it just brings the software engineering best practices to this workflow. So what I mean with software engineering best practices is, for example, using testing. So we would include automatic testing at like all steps of the transformation. So every time checking, for example, is this column unique that we expect to be unique, or is there any random data that we don't expect, or things like that. And another important aspect is version control, which I also just mentioned before. So dbt is very easily integrated with GitHub or GitLab, in this case GitLab, which tracks all of the changes. And it also means that before you make any change in production, you need to get it approved by another member of the team. So that also really ensures the quality of the transformations. And all of these transformations are orchestrated with GitLab, so that means that twice a day, all of these transformations are run automatically, and whenever something goes wrong, like one of the tests fails, for example, there's a notification sent to the team, and they can check what exactly went wrong. So that also reduces the workload for the team, whereas before it was mostly done manually. So then, yeah, people would have to manually run this like every day, whereas now it's just run automatically. Yeah, so I already mentioned a little bit about what transformations we're doing, but you might still be wondering what exactly does that mean, and why can't we just use the raw data and then just put that into our dashboard? Wouldn't that be easier? So to exemplify this a little bit, I have an example of some of our raw data as it comes in a little bit of a simplified format. So in this example, there's just one connection for one interval. So on this specific day from like 10 o'clock till 10:15, this one is consumption data. So that's because customers also often have solar panels, so then that would be production data. And then in this particular case, the usage for that interval was 0.05 kilowatt hours, and it was committed at a specific timestamp. And the quality was estimated, which means that it's actually not from a smart meter reading, but it's estimated by some sort of model. So that looks easy enough. We have this one row for this one interval, but actually then we also get additional rows sometimes for exactly the same interval, the same connection ID, and the only difference is that the usage is different, and also the timestamp is different, and the quality. So we really had to make sure we select the correct, or at least the most accurate row that we can determine. So we came up with some rules for that. So for example, we would look at the highest quality, which in this case would be actual compared to estimated. And then for the highest quality, we would choose the latest committed timestamp, because we assume that the later data would be more accurate. So in this case, for example, we would then choose 0.06 for this specific combination of connection ID and interval. And the same thing then goes also for production. So for this exact interval and connection, we also have usage data for production, and then we need to apply like a similar rule. So in this case, for example, the correct or the most accurate row would not be the latest one, but the one before, because it has a better quality. So these are just some of the examples of the transformations that we need to be doing, but there are actually a lot more things as well. So for example, even if now we selected one of the rows as our most accurate one, there can still be data coming in later for this exact interval as well. So up to 30 days, there can be data still coming in. So then we need to recalculate in an efficient way as well. And we also have data from different sources, like I mentioned before, like we have Kraken and Energy Zero. And this is like the format from Kraken, but Energy Zero could have completely different format. So that also needs to be aligned in a way that it all kind of looks the same and works well together. So the way that we do this in dbt is we're using these 3 layers, which is the DBT best practice for structuring your project. So maybe you've already seen this before today, or maybe you will see this in Lucy's DBT workshop if you're taking part in that. So we have the staging, which is the first part. So this is mostly renaming of the source data. We then have the intermediate layer, which is where the bulk of these transformations are done. So for example, this is where we select the most accurate record, which is what I explained just before. This is also where we change the format of our data to have just one row per connection ID and interval, with then one column for consumption and one column for production, rather than having 2 rows. So that also reduces the amount of data that we have in total, and all kinds of other transformations that might be needed. And the mart is then the final layer. So this is the one that is exposed to Power BI dashboard. And this is where we do some final renaming, and we're also combining the data from our 2 energy sources. So we have all of these different stages where different things are happening. So we are materializing all of this in Snowflake. So you can imagine that is actually a lot of data. So we don't just have that one raw table, but we have all of these models with all of that data again. So there's billions of rows in every single table. So when you refresh all of this, it's approximately 400 euros that you have to pay for that. So the most basic approach would be just to recreate all of this every day. So you need to pay like at least 400 euros every day. I think that's actually pretty low estimation. And as you get more customers, and also as time goes on and you keep all the historical data, this will just go up and up and up. So it will just become very expensive. So there are, of course, better ways to deal with this. So what we implemented at IMBB is something called incremental modeling. So basically, we have our source table. So this is the table that is coming in from the data source, so from Kraken, for example. And let's say that has data until today, including today. And then we have our existing model, which is until yesterday, which is the last time when we ran our transformations. So the new records are the ones that came in today. So what we do, instead of running the transformations on all of the source data, we actually just run the transformations on the new records. So that is a lot cheaper because it's just one day instead of 3 years of data, for example. So we run all of the transformations on the new records, and then we just add them to the existing model. Of course, in reality, it's a little bit more complicated than that, but that's kind of the basic idea. And then we can still run a full refresh when something major has changed in our logic, or when we just want to make sure that we didn't miss any data in between. But most days, we will just be running this incremental logic. And the business impact of that is something you can see here. So on this graph, you see the credits, the Snowflake credits that the DBT transformations have used. So you can see that the highest here is up to around 300, whereas most days it's just around like 25, 30, and you pay a certain amount for each credit. So the more credits you use, it's directly correlated to how much you're going to pay for Snowflake. And you might be wondering, like, why are some days so much higher than others? That's because on those days, we had to run full refreshes on some of the models because something changed. So you can imagine that might seem like a lot, but if we didn't have incremental models, it would be like this every day, or even more, because in this case, we just had to run it on some models, and otherwise we would need to run that on all the models. So it would be very expensive, but also by using these incremental models, in addition to computational resources and financial resources, we also save on carbon emissions, because actually this is also very, it also produces a lot of CO2 to do all these transformations and to store all of that data. So yeah, that already brings us to the conclusion. So as we heard from Kasper, to avoid grid congestion and expand the use of renewable energy, we need to use energy more efficiently than we are doing now. And this requires not only accurate, but also time-dependent data. So that means that we actually have a huge amount of data. It's just getting more and more and more as the smart meters are getting more accurate. And this places a huge strain on data platforms in terms of financially, computationally, in terms of time, CO2 emissions. But all of that we can mitigate by being smart about the way we store our data, the way we process our data. So yeah, to use energy efficiently, we also need to store and process our data efficiently. Right. Thank you.